We're working section 13(1)A, number 25. This is kind of an interesting problem here. We're supposed to find the length of a 36-degree arc of a circle whose radius is 6 centimeters. So here's our circle. We have a radius that is 6 centimeters. And our arc is 36 degrees. Now, if it was telling us our arc is 360 degrees, how would you find the length all the way around the circle?
Circumference, right?
Yeah, circumference of a circle is just if it's all the way around at 360 degrees. So we're just going to have to find a fraction of that circumference. So first we find the circumference, the length all the way around it, and then we take a fraction of that based on 36 degrees instead of 360 degrees. So first of all, circumference is 2 times pi times radius. So we've got 2 times pi times 6. In other words, 12 pi. So if we were doing all 360 degrees, it would be 12 pi. How can I take a fraction of that, knowing that we only are using 36 degrees instead of 360 degrees? The 10th of it. Yeah, we'll just take the 12 pi times 36 over 360. So that's the fraction of the circumference that we need. And 36 and 360, we can divide both of those by 36. So that leaves us with 1/10. So now we've got 12 pi over 10. Is there anything I can simplify here if I put my 12 pi over 1?
Wait. How did you, I'm sorry, how did you know that you needed to divide 36 into 360?
Because I'm getting the fraction of the full circle. So it's
Okay,
a full circle is 360 degrees. And the arc that we're given is 36 degrees. So we just take 36 over 360.
So it would be 12.
okay,
I know.
I would think it would be the difference, like 300. Wouldn't it be 360 minus 36?
Now think of it this way. What if it was just half of the circle? You would just divide it by 2, right?
I don't know.
If you're just doing half of the circle, wouldn't you just cut it in half, divide by 2?
Okay, yes.
Okay, well, that's the same as 180 over 360. That's your half.
Okay,
Okay, but this time, instead of having a half a circle, it's only 36 degrees out of the 360.
okay, got it.
So if we simplify the 12 and the 10, 12 divided by 2 is 6. And
get-
by 2 is 5. I'm getting 6 pi over 5. Are you?
That's what I got.
And what was our units?
Centimeters.
See, I did it by putting it over 180 to begin with.
Is that a arc length formula? Let's see.
Yes, it's the
L equals pi r theta over 180. Let's see if we get
Yes.
the answer when we do it that way. Arc length is I times 6 times 36 over 180. And if we simplify that, let's see, first of all, 180 divided by 6, we can simplify that. 180 divided by 6 would be 30, right?
Yes.
And then the 36 and the 30, we can divide both of those by 6. So we're left with 6 pi over, and 30 divided by 6 is 5. Same thing. To get their formula, they did the same as us. It's just that they canceled the 2 and the 360. So that's why theirs is divided by 180 and it doesn't have the 2. I like my way better. It makes more sense to me. That you're
Well, none of it makes sense to me, but
taking the fraction of the circle times the circumference times 2 pi r. But if you want to use the formula, that's fine with me. Write it on the note part. Okay, so that one was 25A. Part B. Explain why you think that the arc in part A is longer or shorter if the radius had been 8 centimeters.
I said it was longer because simply because 8 is bigger than 6, so it would make the arc different.
Yeah, I agree with you. If you bigger, a bigger circle, I tried to make it, maybe I can drag it there. You make it a bigger circle, but the same angle. Let me just extend this. This arc here is going to be a little longer than this one here. And the radius is longer. So I would agree with you on that. And then part C, find the arc length when the radius is increased to 8 centimeters. So instead of 6, right
So
here,
you work it out just like you did the first part, except you used 8
instead of a 6. So if we did that, if we canceled the 8 and the 180, 8 divided by 2 is, see, are these supposed to be both divisible by 4? Let me see. Yeah, 180 is divisible by 4. It would be 45, and we're dividing it by 8 instead of by 6. 8 divided by 4 is 2. So now we have 2 times 36 over 45. 36 and 45, do they share a common factor?
9.
9. So 36 divided by 9 is 4. 45 divided by 9 is 5. And then we still have this 2 hanging around up here. So we would have 2 times 4 is 8. There's still a pi. And our new denominator is 5. 8 pi over 5. And the units again would be centimeters. Okay, now problem number 26 is going to use the same formula. But this time they give us the length and we're supposed to solve for the radius. So we'll still use that formula where the length, the arc length, which I'm going to put the 14 pi in for L right away. The arc length is pi times the radius times the degree measure, which in this case it's 80. Degree measure of that arc over 180. And then we have to do a little algebra to solve for R now. I see 80 and 180 both end in 10 in 0, so I'm going to divide those both by 10 and just cancel off those zeros. And 8 and 18 are both divisible by 2. And that becomes a 4. This becomes a 9. All right, and I'd really like to get rid of that 4 pi over 9. So I'm going to multiply both sides times the reciprocal, times 9 over 4 pi on both sides. So pi's cancel. 4's cancel. See why I did it? 9 times 9 over 4 pi to get everything to cancel. When you multiply by the reciprocal, it just makes that constant cancel to 1. So we're left with R on the right hand side. And on the left, we've got 9 times 14 pi over 4 pi. So the pi's cancel. The 4 and the 14, we can divide both of those by 2. So we're left with 9 times 7 is 63. And in the denominator, we have 2. So I'm getting 63 halves for the radius. Is anybody else getting that? Yes, and the units is meters. It's question C. No, that was question 26. In question 26, they gave us the length. So we plugged in L. We plugged in the 80 degrees and we solved for R. We might as well do 27 while we're at it because it's about arc lengths as well. Suppose you have 3 concentric circles and are looking at the arc lengths of a 60-degree angle of each. If the radii of the circles have the ratio 2 to 3 to 4, what is the ratio of the arc lengths, do you think? If the radius of one is 2, the radius of another one is 3, the radius of another one is 4. Do you think the arc lengths are also going to be in that same ratio? The next one just a little longer, the next one just a little longer. Yeah, I see Lana shaking your head. Yes, I would agree. It would be in the same ratio. Now, if you were talking about the area of the circle, that would be different because in area, radius is squared. But in circumference, the radius is just r. So the arc lengths would just be also in the 2 to 3 to 4 ratio. But if you were comparing areas, then you would have a 2 squared, the 3 squared, the 4 squared ratio, because in area, the radius gets squared. So if your radius is, radii are in a 2, 3, 4 ratio, the areas would be in a 4, 9, 16 ratio. But in the question they asked a question about the arc length, which is based on circumference, and circumference is 2 pi r, just r to the first. So it would be the same ratio.